Welcome everybody, it's Ramachandra from CIVIL MEch MATHS CONCEPTS channel, and in the first part of this problem, which was discussed in Structural Analysis 11, the first part was solved, and in the first part we have found out the maximum stress in sine wave, which is the limiting stress. That's value is 86,207 Newton per square meter, that is equal to 86,207 pascals, that is equal to 86,207 86.207 kPa. Let me increase the now this 86.207 kPa is the limiting bending stress, sigma maximum. This is what we have got. Now, as per the beam theory, sigma max is equal to m by z max, where z max is equal to I by y max. In the part 2, we will be using, for part 2, we will be using circular beam. Circular beam, what is the value of I? ICG is equal to pi d to the power of 4 by 64. And what is the y max? Y max is equal to from the extreme fiber to the center of gravity, that is d by 2. This is the circle. Extreme fiber is here and this is CG. This is y max. In this problem, we will calculate the x in this lecture. Afterwards, in the next lecture, before proceeding for natural frequency of the cantilever beam, I will provide one more lecture of theory on natural frequencies to find out the natural frequencies in a cantilever beam. After that, we will proceed for this numerical. Now, as per the part 1 calculations, what we have got is sigma max is equal to, that is the limiting bending stress in the factory, 86.207 kPa, that is equal to 86,207 Newton per square meter. Now, sigma max is known, and the circular beam, whatever is there, we will take the details of the circular beam. The details of the circular beam are dimensions. Length is equal to, it is a cantilever beam. It's a cantilever beam. Length is equal to 1 meter. Cantilever beam. Diameter is equal to, D is equal to 50 mm. That is equal to 0.05 meters. 50 mm is 5 centimeters, that is equal to 0.05 meters in SI units. Now, from diameter, please try to understand the concept of beam theory. This is the circle. In this circle, this is center of gravity, and this is extreme fiber. Extreme fiber to center of gravity distance is y. Extreme fiber to center of gravity distance is y. Because of the symmetrical section, circular section, y max is equal to d by 2. Y max, that is equal to d by 2. This is the extreme fiber. This point is the extreme fiber. This point is the center of gravity. And this distance is y max is equal to d by 2. We have got y max with us, the distance from the center of gravity to the extreme fiber. Because it is a symmetrical section, center of gravity could be calculated or could be understood from the geometry itself. Now, we have to find out m max is equal to how much. We have got I is equal to ICG is equal to pi d to the power of 4 by 64. This is also standard value given in the textbooks. You can derive also. I have already discussed in my previous lectures, almost 5 to 6 lectures, how to calculate the moment of inertia about the center of gravity of a particular shape. Now ICG is pi d to the power of 4 by 64. Y max is equal to d by 2. Therefore, Z max is equal to section modulus is equal to pi d to the power of 4 by 64 divided by d by 2. That implies Z max is equal to pi d cube by 32. For a circular cross section, this is the standard value. Please remember this value. This is section modulus. ICG with respect to center of gravity is, this is moment of inertia. Now, once you know the section modulus, maximum section modulus, from that we can say that sigma max, we know sigma max is equal to m by Z max. This is another important formula which you have to remember. Z max represents the strength of the beam. Now, sigma max is known to you, 86,207 Newton per square meter. From this we can say that maximum bending moment allowed is equal to sigma max into Z max. Please remember these derivations, linkages and relationships between different formulae. Now, in the part 2, we have to calculate the load applied at the free end of the cantilever beam. What is the question? Now part 2 calculations let us do. Part 2. This is the cantilever beam. a load x kilonewtons is applied and cantilever length is 1 meter and D is 50 mm, cross section 0.05 meter, and here x is unknown. The bending moment, how will be the bending moment diagram will be there for a cantilever beam? How will be the bending moment diagram? How it deflects? It deflects this way. And when there is a movement like this, it will be negative. That means bending moment diagram will be here at free end moment will be 0 and at the fixed end moment will be the highest. This is the fixed end, this is the beam, and this is the bending moment diagram. This is minus. This is bending moment diagram. Once we know the bending moment diagram, what is the bending moment? Bending moment is equal to, moment is x into 1. Here bending moment, here it is A, let us call it, here it is B. Bending moment at A is equal to, quantity only we are writing, x into 1. X is the kilonewtons, x into distance is 1. That is equal to kilonewton meter. This is x kilonewton meter. This is the maximum bending moment. Here x is unknown, we have to find out. From the equation, m maximum is equal to sigma max into z max. Whereas from beam theory, m maximum, that is equal to ma, is equal to sigma maximum into z maximum. That implies sigma maximum is found out from part 1, 86207 Newton meter. This will convert into Newton meters. That is 1000 x Newton meter. 1 kilonewton meter is equal to 1000 Newton meter. Now, sigma max is known. From this equation, m max is equal to 1000 x is equal to sigma max is 86207 and z max is, z is equal to pi d cube by 32, pi d cube by 32. That is equal to 86207 into, what is pi d cube? Pi into 0.05 cube by 32. That means x is equal to, let us calculate 1 by 1. Very simple, not a tough calculation. Now let us calculate. X is equal to 86207 by 1000 into pi into 0.05 cube by 32. That is equal to pi into 0.05 into 0.05 into 0.05 divided by 32 into 86207 divided by 1000. $86.207 into pi d cube by 32. Pi into 0.05 into 0.05 1.23 into 10 to the power of minus 5. This is the value of the load. This is the value of the load, 1000 Newton meters, 1000 x. Because we have to find out x in kilonewtons. This x value will come in kilonewton meter because x we have taken as kilonewtons. That means into 86.207. That is equal to 0.00. X we have taken in kilonewtons. 11 kilonewtons. That means that is equal to 1.1 Newton. When we, because x in kilonewtons we have taken, that we have multiplied with 1000 to get the moment. Otherwise, if you take x in newtons only, then we will get the value 1.1 newtons. This is the value. Please cross check the calculations. I have done it with my calculator. You can cross check. If you have any differences, please come back to me. We will calculate again. There is absolutely no problem. Don't worry about the calculations here. Answer is not important. Here the procedure, understanding the procedure is more important. That means we can find out the maximum load that can be applied on the cantilever beam based on the limiting stress is 1.1 Newton. And another important thing I want to tell you, here we have not discussed what is the type of the material. If we say the beam, it is very important which I am discussing now. It is a concept. Beam material is equal to steel. For different types of steels, different stresses are there. Allowable bending stress is equal to around 210 MPa. MPa is mega Pascal. 210 into 10 to the power of 6 pascals. That is equal to 210 into 10 to the power of 6 Newton per square meter. If, please see, if we apply a factor of safety that is equal to 3, which implies allowable bending stress will be, these values may differ from steel to steel. in steel is 210 by 3, that is equal to 70 MPa. Please see this, please understand. Whenever you apply the factor of safety, when factor of safety is applied, allowable stress is equal to allowable for material, allowable stress for material divided by factor of safety. Please remember this, because I promised you I will discuss about the factor of safety in this lecture. I am discussing now. Now you tell me, if allowable for metal is, steel is 210 MPa, if factor of safety is 3 is applied, then what will be the allowed bending stress? That will be 70 MPa. What is the bending stress we have got? Applied we have got, applied maximum is equal to 86.207 kPa, that is 0.086 MPa. These conversions you do it on your own, you should understand. kPa is kilo, MPa is mega. This sigma applied is sigma max is very much less than sigma max applied is less than sigma allowable. Hence this design is accepted, but this design is very heavy. Even after applying the factor of safety, the applied stresses are very, very low. That means the beam can go for applying for some more stresses also. In future, if any stresses also do come, we need not change the design of the beam. Now, with these concepts, I want to close today's lecture from my channel Civil Mech Maths Concepts. Now, in the next lecture, I will not be taking up numerical directly. I will be discussing vibrations in beams. Vibrations in beams. After discussing for 2 or 3 lectures vibrations in beams, it's very, very important topic. You should know about it. Many people are unaware. Suddenly, if a question comes regarding vibrations in beams, people will get surprised from where it has come. But however, I am planning to cover this topic because it's very important topic. Ultimately, structural analysis is nothing but structural design. When considering the designs, we have to consider the vibrations also. Vibrations in beams will be our next topic. After completing the vibrations in the beams, then this whatever x we have applied now, with that, what will be the natural frequency? From that we will find out the deflections and other things, whatever is asked in the question. We will go for vibrations in beams in the next lecture. Thank you for listening to me. Best of luck to everybody. And my name is Ramchandra from Civil Mech Maths Concepts. If you feel my videos are giving value addition to your knowledge, please subscribe to my channel, and I'll give the links to my previous videos in the descriptions. You please see those videos also. 57 videos are released as of now. Best of luck. Thank you.